All right, so yeah, thanks for joining. I'm sorry for the issues with the projector and all the stuff. So hopefully now we can get started. So a bit of outline. Can you all hear me okay? I guess if we start messing up with the microphones here, we will never get finished. So a bit of the outline. I will start with CMake and Ninja. Some of you told me that you wanted to learn how to use CMake, that you use Make. So I will give a short introduction to that. You can install CMake and Ninja with Brew. So if you have Brew in the Mac, you can do it on your own now, and maybe you can follow online. And then I will talk a bit about how do we usually work with Python using virtual envs. So virtual env is a way to create an environment, so you can have multiple environments and activate and deactivate them, and have different libraries and different versions of MXNet installed on each. Then I will go into CLion a bit, how to compile with CLion and then debug. CLion uses CMake, so that's kind of related to the first point. And then you also use the virtual env in CLion to use the Python environment that you want.
Can I make a quick suggestion?
Yeah, sure.
The CLion you have documented that, right?
CLion is documented on the wiki.
Yeah, so can you show us how to debug using CLion?
Yeah. So I will go very quickly. Okay. I will just copy paste the CMake settings on CLion, so it will not take a lot of time. And then if we have time, otherwise we do it next time. There is some scripts to start an EC2 instance very quickly and provision it if you want to debug, to compile and debug MXNet. And then there is the menu script that makes it easy to compile and run unit tests in MXNet. It's in the root folder. And then I want also to cover a bit of Docker and how do we use it on CI and in MXNet. And finally, I wanted to talk a bit about this build PI script that we have in the CI folder to reproduce CI test results. Okay, so let's get started with CMake. CMake is a build generator, so CMake doesn't compile by itself. CMake generates build files for other build systems. So if I go to the MXNet folder, let me do a fresh clone of MXNet. I have small alias that clones and adds my private repos. I do it so many times. So yeah, what CMake does, CMake generates build files. So you can generate, for example, Make files, you can generate Ninja build files, or you can generate Visual Studio. So when you invoke CMake, there is the concept of generator. There is one of the flags, -G, and you can choose one of those. So there is several. There is MGB, CMake, Ninja, Unix. The good thing is that you can generate for different build systems, and you only have to maintain CMake ideally. Yeah, so the entry point for CMake is always this CMake lists.txt, and here is all the CMake configuration for MXNet. But what is important for CMake is that when you invoke CMake, here we have it. So usually you want to do an out-of-source build. So for that, you usually create a build folder, you go inside, and then you invoke CMake. So you would do CMake. You want to generate Ninja files, and you invoke it on the previous folder, in the source folder, right? This might fail because I didn't set up the flags. Yeah, because by default it tries CUDA and all this stuff, so let's try to add the flags that I'm going to use in CLion. This is the ones that I use in CLion on Mac. Okay, so now I generated build files in this folder, and what I have generated is for Ninja. If you don't put Ninja, you can also generate Make files, but I would suggest Ninja, which is faster, and you get faster builds, and it's I never had a problem reproducing builds because Make is not as good with dependencies. So now that I have generated the build files, I just do Ninja, and these builds in parallel. By default, it doesn't provide information about the commands But if you want to see the GCC command, you do ninja -b. This is all in the documentation, but just like a quick introduction, right? So now you can see the GCC command line. Anyway, when it's finished, you have MXNet compiled. So this would be kind of like quick introduction to CMake and Ninja. Two things to remember is the out of source builds and generator, and then you specify the flags. As we saw, this is the command line. -g, you choose generator, by default is make, and then you use the command line flags that you want.
I have a question.
Yes.
So why not just make the CMake, like before you specified all the parameters, the CMake failed, right? So why not make the default?
So CUDA is by default on. So when we see the CMake file, we have all these parameters for MXNet declare, right? So the one on the right is the default.
But the CMake can also detect the environment, right? If you don't have CMake can in your script, in your CMake text file, right? You should be able to detect whether your environment.
You could, but we don't have it right now in MXNet. So you can do many things on CMake, but right now we don't do that, right?
Okay.
So for building, you have all these list of flags.
Okay, so you need to manually turn it on and off to make sure it.
Yes, there is also some wrapper scripts that we will go in detail later. So I did some wrapping in Python in this dev menu script that we will see later.
There are also competing libraries.
So I created this in the CMake folder. There is this CMake options YAML where they are defined and they are processed by a small Python wrapper. So you can have yours, and you don't need to do all this command line stuff again. So you can copy this to the root, and then you can do this invocate this dev menu, and use the first one, right? Local build. And since I copy this file, now it fails because it's not configured properly for Mac. So let me copy it. Then it uses the flags from this file, right? Sorry if I go a bit too fast. So there is this YAML file, and there is this Python wrapper script that uses these flags. Let me show you quickly the code so you believe what I'm doing, right? There is the menu API, and then there is this CMake file, the CMake class that is using the YAML file just to pass it to the CMake command, right? You can use this if you want to extend the script or whatever. But basically, what I do, I just copy that file and I just say the menu one, and then it compiles with the options and the details.
For this browsing, for this or YAML file is MXNet for
Yeah, so there is a default one in this CMake folder. There is the CMake options YAML, which is kind of a default one. And by default, it takes this one that has it has CUDA off, but that has something like OpenMP. I can compile with OpenMP on the Mac because I can install any additional configuration. But we will go back to this later. Okay. So now we have CMake and Ninja installed, and I will suggest also that you install Ccache. So Ccache makes builds very fast on Mac, especially if you are developing in these low power machines. If you rebuild, it takes a long time. Probably you have noticed. So I would suggest to install Ccache. You can start with the brew. And Ccache, what it does, you can trust it because it works very reliably. So Ccache caches the GCC invocation command, and it caches also the preprocessed source code. So if this matches, then it will automatically get you the compiled object. So the compiler is only located to preprocess. And this makes things much faster, right? You can do Ccache -s to see the hits. So for example, here I have 42% hit rate. To see how much Ccache size you have defined. So Ccache uses the disk locally to store all the compilation objects. So here I have 10 gigabytes, by default is 5, so maybe you want to increase, probably you want to increase it. And one more thing related to Ccache is that when you use CMake, let's see how we invoked CMake before. If you see here the CMake invocation, we say CMake C++ compiler launcher Ccache. there is several things how you can enable Ccache. One is very easy, that you can say just export cc equals Ccache GCC. This is that kind of the way that I have been doing for years. You also have to export CXX for C++, and these two lines you usually can enable Ccache for any compilation of any project that you do make and make install. So this is kind of like there is another way to set wrapper scripts, but basically you get the take-home message of use this environment variable to enable Ccache. Okay, so that's more or less the introduction to CMake and Ninja and Ccache. You can install all this with Glue. Then let's go to virtualenv. How many of you are familiar with virtualenv? It's a Python virtualenv. Okay, so
Can you type what is? Oh, virtual.
Virtual environment.
yes, so when you work with Python, I would strongly recommend you can Google this virtualenv. Basically, virtualenv you can also install it with Glue or with apt in Linux. So what it does is it's a virtual kind of a big Python environment locally where you can install libraries. The goal of this is that you can have different environments, install different MXNet versions, and switch between them. Imagine you are debugging something, so you want kind of the master and you want the one with your modification. So to do this,
I have a question.
Yeah.
Does it also, you said you can use brew install. Does it install it in the virtual environment? When you brew install inside a virtual environment?
no.
So it's only for Python?
It's only for Python. So I think I have,
Okay, good.
I think release doesn't show what you have installed, right? I think it's installed maybe with Pip. Anyway, you can Google install virtualenv and Mac.
A lot of people use Conda, so do you have any comments about the pros and cons between virtual and
I don't know the pros and cons because I use virtualenv. I know how to use it. I know the ins and outs. So I know that other people use Conda. I don't use it, so I cannot comment. I don't know. If you are happy with Conda, then I guess it's similar, right? I think Conda it does much more, right? So virtualenv is used for Python. I think Conda you can install other types of packages and it's kind of more heavyweight. But I haven't used it much, so I don't know. Okay, so basically virtualenv is very easy to use. What I use is, imagine you want to install MXNet in virtualenv, you do virtualenv -p, you put the Python executable that you want to use. In this case, I want Python 3, so I do which Python 3, and then it will return the Python 3 that I have installed, and I say, I give it a name, Python 3, and so this creates this folder. It's just a folder, right? Now we will see, this creates the virtualenv. If you see video 3, you see that it's just, it's just a directory, and then it has a shell script that you invoke when you want to activate the environment, and this sets the Python, LD path, and all these environment variables that then will make Python use the libraries that you have in this virtualenv. So this is very, very good because you don't want to pollute your global environment. If you do pip install MXNet, imagine you have compiled your own version of MXNet with some changes. If you do pip install, you are then polluting your global environment with this version of MXNet, and then you don't know which one are you using. So I'm going to show you that this virtualenv, I did a tree on this folder. It's just a collection of, it has all the Python libraries and the Python interpreter. So basically to activate, you do source, the directory name, and then being activate. Then by default it changes the prompt here with the name of the virtualenv there on the down on the left. So now I have this py3env activated. So I could do now pip install whatever I want. I can install Docker or MXNet, and then it will install it just here, not in the global. Okay, so you can also choose Python 2, for example. You have when you do -p, you can choose different Python interpreters, and this is very useful, right? And now let's tie all this together with CLion, right? So for CLion, we will use CMake, and then we will use these Python virtualenvs to define which Python executable we are going to use, and also the set of libraries that we are going to use. So I just cloned MXNet against MXNet tar. I will just reset everything. So as you know, we have a lot of subrepos, so to reset, always if you want to reset everything properly, you have not just to do git clean, you have to really reset all the subrepos. So I think I have some kind of aliases for that, but what I would recommend, so you can either...
Can you not do git clean minus d minus f?
So I have this,
Can you not do make
no.
clean for?
So you do it wrong. So if you do just do git clean, you are not cleaning the subrepos, right? And then you have a lot of stuff in pslite and dmlc and all this stuff, so you are not guaranteeing that the build is clean. So you can do these git aliases if you put in your path, like git dash something, this would be interpreted as a git command. So I have this one that is called git subreset. So what it does is, they need, always with git everything is very verbose, right? But it's just going to initialize the subrepos, cleaning the main folder, and then for each subrepo is going to clean it up and update it. You can also use in that menu that is the same, you can use there is an option to reset all the repository. But you have to be careful, so if you have local changes, of course, it's going to remove it, right? So in that menu, you can do number 10, which is clean. You have to confirm, and that's the thing. So as you see, enters the subrepos and everything. So when you have some problem, you have to make sure basically that you are cleaning the main repository and also the subrepos. This is the take-home message of this one. So now I clean, everything is in the same status as if I would have clone. I'm in master, with this commit. If I do update the subrepos, nothing happens, so I'm good, right? So I will go to CLion, and I just open the project. It's called MXNet, this one that I just cloned. And I open it, so the first thing I have to do now is to configure CMake. Because as before, here, by default CUDA is on, so CMake is not able to run. So I go to preferences, then I search for CMake here, and then there is build, execution, and deployment, and the CMake part. So you can say automatically reload CMake project on editing. So if you edit the CMake file, it would regenerate all the build files as we saw before. Okay, so the bug is fine. Toolchain, I'm using the default. I didn't install LLVM. Let me copy all this line, the ones that I use now. Here in the environment. Oh no, not in the environment, sorry. CMake options. Yeah, so I pasted on CMake options. So we have CUDA off, OpenMP off, OpenCV on, no MKL. You can do verbose make file there is more verbose on the generation if you are working on CMake, that's useful, and then the two lines to enable Ccache for C and C++. Build options, you can say -J4 because CLion is going to use make. You cannot use Ninja, there is no option to use Ninja. So you have four cores, you can use -J4 or -J2, this is the parallelism, right? So I say, okay. As you see now, CMake is being invoked and it's generating the build files. So it's finished, okay, everything perfect. So now we can just work on the project. I think now it's indexing, building the symbols and everything, but we could just build. And yeah, we can also run. So let's see how we would debug MXNet. Maybe I will then open the one that I have already compiled because otherwise it's going to take forever. So So basically what we have to consider when we are going to run and debug in CMake, we need to consider where is the MXNet library. So when CMake builds by default, the output folder is in this CMake build debug. I don't know, can you see or should I make it tell you? By default it is in CMake build debug, and here I have it compiled already, and you can see that this is the dynamic library, this is the MXNet library. There is an environment variable that is documented in this docs FAQ n.
So do you use CLion to edit Python and C++ code?
Yeah.
How do you resolve all the paths?
Which paths?
The Python paths.
Yeah, I'll go into it. So one very important variable is this MXNet library path. If you use a virtual env and you install with pip, then you don't need to set this up. But if you want to redirect MXNet to a different library, you can give an absolute path and you can say export MXNet library path, and you could say I don't know where am I, right? So you could say export. This is independent of the virtual env. So this variable is used at load time by the libinfo.py inside MXNet to choose which library is going to use. So if you change this, independently of virtual envs and everything, MXNet is going to try to load this library. So you set an absolute path. For example, in this case, I could say the one on that CLion is producing, and then I will make sure that MXNet is using this library, because I could have several laying around. So this works the same when you want to debug with CLion. You don't need to set it all the time. So just be aware that by default it's going to load the MXNet library from predefined folder that is in the info, but if you set the environment variable, then you force it to use the one that you specify.
Can you not do it? I saw that you could do it right in the configuration, right? There is a Python interpreter and you can change the Python interpreter paths.
Right. So now when you want to configure CLion to run or debug, you need to do two things. So you could either debug an application, which means a C++ binary, or if you want to start from a script, let's say you have a script that's used in MXNet. In this case, I have this, I guess I configured yesterday, this mlp.py. So we can see that it's just a Python script that is used in MXNet, right? So in this case, I need to say, okay, I want to use a Python script. You say new, you click on plus and all this stuff, and then you give it a name. You set the script path. And then you could change environment variables. Here you could put this MXNet library path. By default, you don't need it, because here it says use specify interpreter. And this interpreter is using one of the virtual envs that I have locally. So as you see, it's Python 3.7 MXNet. If we go to the CLion preferences, we search for virtual env. Here you can configure the Python virtual env that you use in CLion. So in this case, I have this one in MXNet. It's called py3_vm. It's just that one that I creates automatically with the step menu. To recap a bit, basically, either you create a virtual env manually, or if you use the scripts, it's the menu thing, it will create this py3vm for you, and then it installs MXNet that you just compile there. So from CLion, you can just pick it up. Like, one possible gotcha is that you have to do pip install in this virtual env every time you recompile MXNet. Otherwise, you have to set this MXNet library path variable. So sometimes there can be confusion of which MXNet version you're using, but basically in this case, I will use the one on the virtual env. Yeah, let's go back to the configuration. So in this configuration, I have a script is using the virtual env here. and it's fine, right? Then I can say, for example, I can say debug or run, and I would put a breakpoint. I can put a breakpoint now on any C++ source. And then, let's see, let's try to put something, this API. What is something that is going to always, maybe this one. I was working in the script, so I don't know if the
Get operator.
huh?
Get operator names.
Operator,
OP name.
OP,
Yeah, name.
Underscore.
underscore what?
OP name.
Name?
I don't think there's just OP name.
This is the C API?
Yes, in the same.
List of, or it's in .h. It's not defined here, CAPI.h. List of. Yeah, there you go.
So you should be able to find it in the CAPI.c.
Okay, let's say I just do
It's
the
written
back.
somewhere else.
Let's see if the breakpoint hits. Okay, so we hit a breakpoint. I think this maybe I put a breakpoint in Python, so by mistake. So
The one on your left.
Yeah.
Finish. I don't think it's stuck. It's already passed.
it's not hitting any breakpoint, right?
I think CLion started.
Did you build that as a debugger?
Yeah. Anyway, we can go into more detail later, but it's basically the way you would debug. So if maybe you try it, and if you have some issues, then maybe we can talk about it. Or
Question. Have you tried the remote debug?
no, I haven't, because I'm very conservative in these things. So I know what it works for me, and I try to stick to it. But here in the wiki, it's documented. So Jose documented how to do the remote debug, and you can try, and if it works for you, maybe it would be good that you share it. I think it works, but I had a very powerful machine, so I didn't need to do this remote
It's
debug.
using GDB or is it using the
What?
This mechanism? Is this using the GDB server?
So I'm using local. It's using GDB server, but locally, so I'm not doing any remote.
Okay.
You can use remote development and remote debugging with SSH, and here there is instructions on how to set that. I personally don't use it because I want to add more entropy to my workflow, so I already know my workflow. So if you use it and you have some things to share, then that's great.
Yeah, this one rsync takes a long time.
It takes longer?
Yeah, I tried with IntelliJ to do this and just building across.
With SSH.
Sorry?
With SSH, right?
Yeah.
And it takes long. Yeah, so.
It tries to send everything. It doesn't do it different.
Yeah.
Send it, so try to send all dot files. And
So yeah, in
that's
Berlin I
my
had a
experience.
32 core machine, so I didn't to do any of these funny things, right? So I think if you use Zcash locally, it compiles very fast, so I think you are okay on the Mac. So just use Zcash, and then usually you are fast enough. Otherwise, yeah, figure out if this SSH works faster for you, and then share it with us. I don't use it. So all right. So any questions about the CLion and the debugging? I don't want to go into like a live demo now of debugging because like I need to hit the breakpoint and everything, but it works. So trust me, if you have some issues, just let me know, because I think it will be very boring if I now put breakpoints. But basically, that's the way you do it. Okay, you go edit configurations, you choose what to execute here. If you want to do a unit test, for example, you will do application. You would say new application. Then you would select the target MXNet static, for example. And then you can say the program arguments. In this case, important is the Python interpreter, right? So the program is Python, and the argument is for example, the unit test that you are executing. So in this case, for example, I would just copy from the environment. I'm going to specify the Python interpreter. So let's say this is kind of the only thing that you need to remember from this. The program, no, argument, no, executable. I need to select other, and I will do. I will go to the virtual M. Python. It's a link, but it works anyway. Okay, so the executable is Python, and the program arguments. Let's say, for example, in this case, I can debug my small Python, my Gluon thing that I'm working on. So, working directory, the local path should be correct, but I'm just going to set the local thing there. And here you can set environment variables, like for example, this MXNet library path or other of the environment variables that are documented in docs, FAQ, and .env. So I do OK.
What's the target MXNet static? Is that something preset or?
So the target, when you deal with CMake, you have different targets, meaning one of the targets is the library. Another target is the C++ executable for the unit test. So when we talk about targets, we are saying in the build folder, there is, for example, this into reg, there is one target. In tests, there is also this binary MXNet unit test, right? This is the C++ unit test that I can execute. This is another target. And there is a bunch of, so I would be supposed to execute this one, right? And that's the C++ unit test. There is also a bunch of other targets that CMake is introducing. I think most of them you don't have to care about. So basically you have to care about the MXNet static, the library. And if you would want to debug a C++ unit test, so this target here just says which target you have to recompile in case you reveal and stuff. For example, here you have this DMLC. So the DMLC is a subrepo. So here it says another target. Here is the MXNet unit test. So all of these binaries define targets. It's kind of a compilation output, sync of it as compilation. All right, so I think I did it, and then I can say debug. Let me put some kind of breakpoint. I don't know. I think backwards should be.
You put a breakpoint in the Python code, and then.
That's the thing. So you cannot debug simultaneously Python and C++. You either have to decide to debug Python or C++. I didn't find a way to debug the two very nicely interchangeably, right? So if you find a way, just tell me. I didn't find anything in Google. Because here, when we set the configuration, we are saying, okay, I'm debugging this, it's a native debugging, right? Because I said application. You said this Python as before, you're debugging the Python one.
So you can't jump from Python to C++?
No, so you can start from Python and then hit a breakpoint inside C++, but you cannot just step line by line in Python and then step line by line in C++. I don't know how to do it, so if you figure out, it would be very useful, but I don't think right now you can do it with this.
Can you do that with Visual Code?
It's two debug sessions.
Yeah,
so you build the debug the Python at the one time, and once the module loaded, you attach the.
If you load a debug version of the binary.
Yeah, you can attach to the process.
Yeah.
Right? When you debug, you can say attach to the process.
Yeah.
And in one window, you can debug through the Python code. Another window, you debug through the
So that would be very useful if somebody can share how their workflow with the two debugging works. I usually either debug in C++ or in Python. So if somebody knows has a nice workflow, then it would be very useful. Okay, let's try to see if it hits quickly, and then let's move on to something else. So I haven't used this Visual Studio Code that I think some of you use, so I don't know if it's better or not. I'm usually very productive with this CLion and PyCharm, so if somebody else knows how to.
I think this is useful. CLion is pretty
Working directory somehow.
powerful.
So use maybe try it a bit if you want to use it, and then if you have more, if you think it's worth going to more detailed debugging, C++. You see now we hit something. So list alloc names is called definitely. We have the stack trace here, and yeah, we can just debug C++, but you will not go into Python. So the trick here is that usually you have to think, okay, I want to debug some C++ function. How to get into this function from Python? So yeah. So you can just continue with F9, and then again, we are listing the operators a few times. Now
If you build the debug with debug symbol, wouldn't the Python debugger show you the stack trace or something, at least the first entry point?
in Python?
Yeah.
So you see the stack trace from the Python interpreter, but you don't see there the Python code where it is. Maybe it would be possible to make a CLion plugin that, because with the native Python stack, you somehow could see where you are in the Python code.
Yeah.
So
Transitioning that from there to the C++ is the one.
I think it should not be very difficult to do a GDB plugin small script that can tell you which Python you are, just to know. But so far I haven't done it. Okay, so now this is running, right? And if you stop it, let's stop it. Should be stopped on some. No, wait, I just stopped it. I could pause it to get started. Okay, so
Is it to just explore different functions in CLion?
CLion works really well for code navigation. So
Yeah.
it's
Example.
called,
Can we try this?
can we tell what?
Yeah, can you just show us how to explore?
To explore the code?
Yeah, just show example.
Yeah, basically the shortcuts that I use the most is Control V to go to a function definition. For example, I'm here in DML registry, so I use Control
It's
V.
same as PyCharm.
Okay.
It's the same family. All the shortcuts are same.
But usually in C++, there are a lot of function overloading, so how do you select between which one you want to go?
I think if there are multiple choices, it works from.
It works 90% quite well. But for C++, it's a lot, right? So basically, the Control V to go to a definition, or you can say, you can do right click, and you can say find usages, or go to either declaration, definition, or type declaration, right? So this is basically what you need for navigating. And then there is the global search, is a two times shift, and then you can type here a function, for example, this list, or how to say, or of names. You can do symbol search, or there is this kind of like global search which gives you all the results, and then you click and then you go. So yeah, again, Control V goes to the definition. You can do find usages, which is also Alt 7 or something, and here it says where this function is used. Another useful one is the Shift F6 that you can do refactor, so you can change the name and it changes everywhere. So this kind of like generic IntelliJ, CLion stuff that you can use as well. So I don't know if we will have time to finish everything because there is 7 minutes left. So what we can do, I can show you these EC2 scripts to start instances. Because, I don't know, so usually if you work with the instances, it takes a bit of time to set up the environment and everything. So what people do is they leave them running, and then there is this AWS scope, and teams spend a lot of money and whatever. So basically what I do is I just start an instance which has terminator shutdown, and I never leave any state. So I have this script that sets it up very quickly, and then I turn it off when I'm done, and I don't hold any state on the instance. There is this scripts that you can use, or you can adapt to your own. They are in GitHub. There is this easy to launch scripts. And basically what it has an entry point that is launch PI that uses bottom. And this chooses, it has very nice things. So you can just specify which Ubuntu version and chooses the AMI for you depending on the region. So all this clickety-clack that you have to do in the console and choosing AMIs and stuff, this you don't have to do it with this, it's a waste of time, right? So I automated all of this stuff. And then it has, it uses Ansible. Ansible is a tool to provision machines. So it uses Ansible to configure the instance. In the Ansible works with a YAML file, but this is playbook.yaml. And in this file, you can very easily, instead of doing a lot of shell scripting and this kind of very fragile stuff, you can define here the packages that you want installed. So if you just want something else, like you have CMake and Ninja and everything.
How is this more useful than DLRM? Why do you use it and not the DLRM?
DLRM, well, I want to know exactly, this is like defined, right? I know the instance that I'm using, I know the Ubuntu version, I install the packages that I want. I install MXNet myself, so I know exactly what is there. And
okay.
So DLRM you can use, sure, it has MXNet installed already and Conga and all this stuff. Right? So with this, I choose my CUDA version, so everything from scratch, right?
I see.
I don't know if you have used Ansible before. It's actually quite easy and nice. It's kind of stateless, right? So you can trigger this playbook on the instance several times, and then it will not install what is installed. It will not change what is properly set. So you kind of define a state. Yeah, and it also installs Docker, right? You need Docker for reproducing all this CI stuff. So this already installs Docker. Another nice thing of this one is that when there is ephemeral block storage in the instance, so some instances, as you know, they have a local hard drive attached to them, SSD, which is very, very fast. It's 10 times faster than EBS. So EBS takes time to warm up, it's super slow. It really speeds things up when you have your home in this ephemeral block store in the instances that support that. But you know, there is this ec2instances.info, and then there is instance storage, right? This is ephemeral storage, meaning that if you stop the instance, these disks are erased, right? So this is, if you stop it and start it again, the ABS volume goes to a different physical machine. So this ephemeral storage is erased. So let's see how I just do launch. So basically the things to consider here, there is the playbook YAML, which is the Ansible configuration, and this launch template file, which defines the Ubuntu version that you want to use. It chooses the AMI for you, otherwise you comment this and put the AMI here if you would like to use VLAN or something. You set the instance type, a name that will be set in the EC2 console, and the username that you want to use. Otherwise, it uses by default the one that you have. And here I'm adding some EBS volumes that will be combined in a software RAID automatically in this MD0. I just do launch. It asks me what's the instance name. I just click enter. The instance type, okay, C5. You will get my SSH key and everything, and the Ubuntu release, you can just type the name instead of having to look the AMI ID. This tries to set up the SSH key. It gives an error that ignores because it's already set up. It says a security group, and then it launches the instance. It takes a couple of minutes, and then when the instance is running, it will trigger Ansible and configure the environment. So basically, if you copy your BI configuration files and add your home folder to this home dir folder that is here, in this home dir you can put your local configuration, your home folder, and this will be automatically installed in the instance. So you have your Tmax configuration or your screen configuration, everything, you put it there, and that is very comfortable because the instance will have your environment right away. So I have one running already, while this one provisions, I can show you. I can go to the console. So I have one that I started before, and the one that is now initializing, that it will provision. Yeah, and that's just like normal, right? You can clone MXNet and then compile and whatever you want. So I think we are already 11:30, so we are missing a bit of an intro to Docker, because I think some of you were not so familiar with Docker, and we are missing a bit the CI, reproducing CI results, and using this build PI script. So I think we can then leave it for a different session. What do you think?
Yes, please.
Yeah.
We can do another one. So did you have any questions then from what we saw before, and then we leave the rest for a second instance of this. Any questions? Okay. Then we do another one going into detail with the compilation scripts and Docker and the CI results and all this stuff. Thanks for coming.
Thank you.
See you next time.